Bet you couldn't do it.
Bet you I can.
How can you be so confident?
Let me explain. Pass me that pen and pen. Right lads, so in order to hit that crossbar, we've got to know about our projectile motion. With a simple and straightforward understanding of projectiles, we can work out the required speed and the required trajectory or angle that we need to kick the ball at. So before we get into all the maths, let's collect some basic stats that we will have. So the distance from the goal line to the edge of the 18-yard box plus an extra 2 yards is 20 yards, which converts into 18.29 metres. The height of the goal is 2.44 metres, which is important as this is the point on the crossbar that we will be measuring the projectile to. Now after a bit of research and testing, I believe I could kick that ball at around 15 metres a second on a standard lofted free kick style attempt. Maybe. But that's what we got, so let's just go ahead and use it. And there's got to be a few assumptions in there as well that we will take into account. The ball will be perfectly spherical in this example, as the drag due to the stitching on the ball would decelerate the ball at less than 5% anyway. Also, when in flight, the ball will have a laminar motion, and we should explain why a little later on. So let's get some symbols cleared up before we start. X will equal the distance in the horizontal plane, Y is going to equal the distance in the vertical plane, U is going to equal the initial speed, V is going to equal the final speed. T is going to equal time, and G is going to equal the acceleration due to gravity. Now we can see in the bottom right there is a vector diagram showing in the vertical direction. We have V sine theta, and in the horizontal direction we have V cos times theta. To show that we will bring trigonometry into these calculations. According to the distance equals speed times time, we can say that x equals Vt times cos theta. And then if we look at the vertical direction, or y, we can see that y equals ut times sine theta minus a half gt squared, from s equals ut plus a half at squared. Then let's substitute equation 1 into equation 2, and you will get y equals x tan theta minus gx squared over 2u squared cos squared theta, which simplifies down to y equals x tan minus gx sec squared theta over 2u squared. Now, using the trig identity sec squared theta equals 1 plus tan squared theta, we can simplify the previous equation into y equals x tan theta minus gx squared over 2u squared times 1 plus tan squared theta. Then by simply expanding the answer that we retrieve, we come up with 0 equals minus gx squared over 2u squared times tan theta plus x tan theta minus gx squared over 2u squared minus y. So it's getting a bit messy with all these tan thetas. So let's replace tan theta with p, which gives 0 equals minus gx squared over 2u squared times p plus xp minus gx squared over 2u squared minus y. Now we can identify there's a common denominator here, which is gx squared over 2u squared. So now we can write that equation as p equals minus x plus or minus the square root of x squared minus 4 times minus gx squared over 2u squared times minus gx squared over 2u squared minus y over, well, that's all over 2 times minus gx squared over 2u squared. Now we are left with something in which we can start cancelling the terms with. So it gives p equals u squared plus or minus the square root of u to the 4 minus g times gx squared plus 2y u squared. And that's all over gx. And then let's replace p for tan theta, and you get the second equation there. So let's plug in some numbers now. And we will plug in u equals 15, x equals 18.29, and y equals 2.44. This then leaves us with two answers for tan theta of 0.301 and 2.21. And then the two angles we could kick the ball at are 16.75 and 65.65 degrees. I'd say the most ideal angle would be 16.75 degrees, as this will require less projection to hit the ball at, and at 50 meters per second the angle of 65.65 will shoot straight up in the air and most likely fall short of the crossbar, due to being in the air a longer amount of time. However, this all neglects air resistance. According to Newton's first law, the object will stay in constant velocity if there are no external forces acting upon it. However, there is a net force opposing velocity. Therefore, the ball will be decelerated in flight in the horizontal and vertical components, as shown earlier. Therefore, a drag is said to be created which lies proportional to the velocity of the ball. The max height and the speed are reduced due to air resistance, and this means that in order to compensate for these factors, I will need to kick the ball harder. With air resistance, the flow of the ball is not laminar. A fluid has a coefficient of friction, and a football, which is a sphere, has a value of around 0.39 in air. This means that with this drag coefficient, the ball will be moving about in the air. It won't stay perfectly still. Therefore, with different forces acting on the ball at all times, there has to be consideration for this factor. In order to do this, we will need to solve some differential equation, but to be frankly honest, they're an absolute nightmare to get your head around, and plus, I think it's time we play some football, guys.
I bet if either you can't.
Alright then, let's go.
Yeah, someone called Bob and Fred. How do they get down the field? Oh, look. See, there isn't any wind today.
Yeah, I know, and the air just feels... What's the word? Just
Density?
Yeah, just average. It just feels average today. Anyway.
Freddie Lazar.
Go back and do it again.
Freddie Lazar. Pro crossbar. I hate you.
First try, Oscar Dubois.
Select I that's what we make you. Kinda much off the speaker. Great day, off a dodge. Interselector.
Engineers, we use precision. Yeah, go! Matter, it's fine.
One eternity later.
Now bad boy, are you ready for the bass? My DJ, yo, get on the case. Sit, rinse it down. Using the mic with a winning sound. Winning sound. Winning sound. Get hyper.
Don't need anybody else around, no matter what they told hold us. Gravity won't hold us down. Even gravity can hold us. Even gravity can hold us down.
Make the ground shake.
Don't you know, beautiful, don't you know, no. Live your life, let that love inside. It's your life, your beauty's deep inside you. Don't let them bring you down, no. The beauty is inside of you. Don't let them bring you down, no.
Told you I could do it.
Here you go.
Cheers.